In this tutorial, you learn how to start using physics in Unity 3D both for 2D and 3D objects. Now first, let's tackle physics for 2D objects. Let's create an empty sprite and just select the default one, maybe this one, background. And then make sure the position is at 0, 0, 0. The camera is at 0, 0, negative 10. After that, let's scale the sprite up so we can quite see it. By holding shift, we can maintain the aspect ratio of the sprite. Okay. So let's say like that. We can now position it to anywhere we want as long as the Z is at 0. So we can see it in front of our camera. Okay, now so it's a plain sprite with nothing in it, just the sprite renderer. Now we're gonna add physics to it. You can click here, add component, type in rigid body. All right, so rigid body, this one, the first one is used for 3D. So later on, I'm gonna show you how to use this component. So for this time, we're gonna use this one, rigid body 2D. All right, so just by adding rigid body 2D and without changing any of its properties, we can play the game and immediately gravity will pull our object down. So that's the very basic of how to use physics to our 2D object here. Bottom line, any object or any sprite or any object in your game that you want physics to affect that object's behavior, just add this component, rigid body or rigid body 2D. So in this component, these properties will affect how physics work to the specific object. So for example, the gravity scale, meaning this will be multiplied to the current global gravity value. So for example, it's 2, it will be the global gravity times 2. So it'll fall much faster. Well, 2 times faster. Then okay, so let's make another 3 more sprites just to see the interaction between them. So let's name this first as falling object so that we don't get confused. Okay, create another sprite. Select background and let's change the color. Can we change the color? Yes, we can. All right, so let's scale it up again. Hold shift to maintain the aspect ratio and keep it square. Okay, so let's put it here. We don't need to add rigid body to this one because we don't want this to be affected by physics. All right, so we'll just leave it here. And then let's duplicate this one. You know what? Let's rename it first. How about foundation? Okay. So right click and duplicate. All right. It's fine to have that parenthesis 1. Okay. And then let's move it right here. And then let's make another one by duplicating this and renaming it to let's say platform. All right, so this one we're gonna stretch it out like that. Don't mind the ugly graphics for now. We're focusing on physics. Okay, so you can extend it a bit. All right. Okay, so let's play it. All right, so nothing happened. First of all, because of the sprite is not at 0. These new sprite are not at 0 Z. So just make it 0 for these 3 sprites. Play it, and now we see them, but nothing happened, right? No interaction between the objects or between the sprites. The reason is there's no colliders. All right, so physics work with colliders. So that's a component that says, or that tells physics that here is where I'm at. All right, so it doesn't see the sprite, it sees colliders. Physics engine sees colliders, not sprites. Okay, so first let's add component to this platform and add collider. Okay, so there's a lot of options here: box collider, box collider 2D, capsule collider 2D. So in this example, or in this activity, we'll choose, of course, the 2D versions, or this one, box collider 2D. Okay, so as you can see, there's a slightly green border instead of white earlier. So that's the collider. If you select this, or if you click this button, edit collider, you can edit the the collider box. So let's somehow move the edges of the collider similar to our sprite. Okay. So now if we play this, you can unselect this. So you can see the white box is the border of the sprite, and that doesn't necessarily mean that the sprite or the image that the player is seeing is reaching those edges right here, right? So you adjust your collider to somehow make it similar to what the player is seeing. Okay, so we move the box collider near this edge of the sprite. So if we play this, nothing will happen still. And why is that? Because although we have a collider attached to our platform, we don't have a collider attached to our falling object. So we add the box collider again, and still same thing. The collider is visibly larger than our sprite, so let's adjust it. You can hold Alt or Option to adjust both sides. Okay, now we can play it and see the effect. Okay, as you can see, it interacted with the platform without the platform having a rigid body component. The only thing that the only object that has rigid body 2D is our falling object, and that's fine. Since we don't want this object or the platform to to be affected by physics. It's just there to be considered by physics. Okay, so every object or any object that has a collider will be considered by physics engine, but will not be affected by it. Okay, objects that have rigid bodies will be affected by physics engine. For example, the gravity. If some other objects hit it, it will fly off, so something like that. So next is, let's add a collider to this object. Still box collider 2D, since we're working in a 2D project. Okay, so let's adjust the colliders again to make it reasonably pretty. Okay, so but as I said earlier, the platform won't fall. Let's play so you can see. The platform won't fall even if this one has collider and this one has collider, because this one doesn't have a rigid body. So let's add a rigid body to the platform as well, so it will be affected by gravity. All right. So to recap, the falling object has a rigid body and has a box collider. The platform has a box collider and a rigid body. It doesn't the sequence doesn't matter. We can actually switch this to our box collider here. Okay. So the sequence of the components doesn't matter. And then this one doesn't have a rigid body. It just has a box collider. So let's play. See? So that's quite fast. So the platform fell and hit this object here. Let's switch to scene. So the platform fell and hit this non-rigid body object here, but with a collider. And then it actually it didn't topple down until this falling object hit this platform. So if we move this one to the left, after the platform fell, it stayed to its place until you apply some more force to it. So that's the purpose of this white box right here. See? So basically, that's how you work on physics in 2D environment. So let's move on to 3D physics. Okay, now after creating a blank 3D project, so let's create, instead of a sprite, let's create a cube. All right, so we now have a cube, and let's switch to game so we can easily see what the camera sees. Okay, let's switch to orthographic by clicking this small cube at the center of this gizmo. All right, or this axis representation or whatnot. All right, so as you can see from this very small panel here, this is what the camera sees. So we can adjust and rotate it so we can have a better view of what's happening or what's interacting with our objects. All right. Now, similar to our 2D project, let's make this cube fall first. Okay, so let's bring it up. Let's bring it up a bit more. So there. Okay. Now this cube needs to have what? A rigid body. A rigid body. But instead of 2D, of course, we select this rigid body, which is for 3D objects. As you've observed, there's already a box collider here. So typically 3D objects automatically add colliders to it. So no need to add box collider. And as you can see, it's not a box collider 2D. Like what I said earlier, box 2D collider is for 2D projects or 2D objects, and box collider is for 3D objects. Right, so let's play. And okay, the cube fell. So that's expected. Now let's duplicate this cube. And then okay, so but since we duplicated it, there's also a rigid body. So if you play this, both of these cubes will fall. All right, so it's fine. So we'll just make this second cube as the platform. We're gonna mimic the scenario from our 2D project. So let's scale this one. like that. And then the last one is duplicate cube, but remove the rigid body. So we can have something that won't fall due to gravity. All right, so something like that. Okay, you know what? Let's make it a bit lower so we can see that the platform is falling, and this one a bit higher. Okay, let's check. Okay, so from the game window, you can see what the camera sees. So it's all of them are visible, so we can play it now. All right, so we managed to create the same scenario with our 2D project. Once again, let me show you what happened. So the platform fell and hit this cube, which doesn't have a rigid body. So this one cannot be affected by the physics engine. It just has a box collider, which can be detected or can be interacted with objects that have rigid bodies. So the platform has a rigid body, and it does fell due to gravity. Same thing with this cube, or actually this is the falling object from our earlier scenario. Okay, so let's play it one more time. And there we have it. That's how you use physics in Unity for both 2D objects and 3D objects. Now, if you learned something from this video, help me produce more Unity tutorials by liking this video and subscribing to this channel. Have fun!